I'm going to walk through some proofs of using CPCTC on DeltaMath. So we're doing just some level 1, so pretty basic, but we are going to use CPCTC. Now, in my instructional video, I explained that we know we need to use CPCTC if our proof statement is something other than triangles. So this one isn't going to need CPCTC. So I'm going to click on New Problem until I get one that does. So here again, this one is just proving triangles are congruent. And I don't want that. So I am going to keep clicking until sooner or later, or not. Thank you. Here we go. Okay, so my proof statement is something other than that two triangles are congruent. And that's what we're looking for, so we can get some practice with CPCTC. All right, so here is our triangle set up here. So we've been given that side AB, and here, let me hover over that. AB is congruent to CB. We were also given that AD is congruent to CD. And then what we're asked to prove is that DB, so this piece right here, bisects this angle, which means cuts it into two equal pieces. So basically what we need to do is show that these two angles are congruent. First thing we need to do is show that these two triangles are congruent. Then we can use CPCTC to show that these two angles are congruent. And then we can say, well, if these two angles are congruent, then DB is obviously cutting that angle in half. All right, so first up, we need to prove that these two triangles are congruent. Well, we have two sides. We don't know anything about those angles. We're trying to prove those. We don't know anything there, but we do have this duplicate side here. So I'm going to look for congruent segments. So BD is congruent to itself, and we know that's reflexive property. So now we know that this side is congruent to itself. So this triangle is congruent to this one using side, side, side. So I want my triangle statement. So I'm going to call this one ABD. So ABD, which means I'm going to call this one CBD. And my reason is side, side, side. All right, so now I know that these two triangles are congruent to each other. Well, if these two triangles are congruent to each other, I know that angle A and angle C are going to be the same. I know that this corner up here angle is going to be the same as that one, and then same thing down here. But the one that we're trying to prove is that ABC is cut in half. So I'm going to look for congruent angles. There we go. So I'm going to call this angle up here ABD. So ABD is this angle right here. And I want to show that it is congruent to this one, which would be CBD. And the reason that's true is because corresponding parts of congruent triangles are congruent. So now we know that those two angles are congruent. Well, if those two angles are congruent, then that must mean that DB cut angle ABC in half. So we want to, here we go, put a bisecting segment, or statement, sorry. So DB bisects ABC, and that's what's written in our proof statement. And the reason why we know that is because that's what, here you go. A segment that divides a larger angle into two congruent angle bisects that larger angle. There you go. So what this is saying is that this segment divided this big angle into two congruent smaller angles. All right, so we'll try that and submit. Yes, and we got it. All right, let's look for another one. Nope, because we want a prove statement that doesn't have the triangles on it. All right, so this one, let's take a look here. Okay, so here's our picture. BD BD right here, and AC bisect each other. Okay, very interesting. And then we're trying to prove that AB is congruent to CD. All right, so AC and BD bisect each other, which means when they meet, they cut each other in half. So when BD crosses over AC, it makes two equal pieces here and here. So I'm going to start with congruent segments. So I know that AE is the same length as CE. And I know that because BD is cutting it in half. So a segment bisector divides a segment into two congruent segments. All right, so it said that AC and BD bisect each other. So when BD, which is a bisector, divides this into two equal segments, that's how we end up with that. All right, now AC is cutting BD in half. So we want to do the same thing, but for the other side. So I'm going to say that BE is the same length as DE. All right. And the reason is the same. So a segment bisector divides a segment into two congruent segments. All right. So now I know that this side and this side are congruent. I know this side and this side are congruent. So I have two sides. Now I'm being asked to prove that AB is congruent to CD. So obviously I don't know that information. So we're going to have to look for something else. If we knew that the sides were parallel, we could use alternate interior angles. But we don't have that option either. But we do have vertical angles. So these two angles right here are going to be congruent. So I want congruent angles. So this one, the top one, I'm going to call AEB. And it is congruent to CED. And the reason is they are vertical angles. And vertical angles are congruent. So now we have this. All right, so this now proves that this top triangle is congruent to this bottom triangle by side angle side. So let's use our triangles. So now we know that AEB is congruent to CED, and our reason was side angle side. All right, so let's apply that. Okay, now that we know that these two triangles are congruent to each other, we know that that means that the three parts that we didn't know before, we now know. So we know that AB is congruent to CD, which is what our proof statement is right here. So I want to get congruent segments. So I'm saying AB is congruent to CD, and that's because corresponding parts of congruent triangles are going to be congruent. All right, that takes care of it. So submit, yes, and we got it. All right, let's see if we have time for another one. And again, we're going to keep clicking until we get to one that doesn't have a triangle. Okay, so here we have some angles. All right, so, wow, look at this picture. Holy smokes. Okay. So we are given that AB is congruent to AC. That's already marked on our picture. We know that triangle BDE is congruent to CDE. Okay? And we're trying to prove that BAD is congruent to CAD. All right, so here's the deal. So we know these two sides are congruent. What we need to prove is that this little angle up here and this one right here are congruent. So we need to get these triangles, either these two, or we can get these big ones like ABE. Okay? All right, so first up, we know that those two sides are congruent, so that gives us a side. And we know that those two triangles are congruent. Now, if we know those two triangles are congruent, that means that BD and CD are congruent. DE is obviously congruent to itself, and BE is congruent to CE. So I'm thinking we go with side, 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 which is just one option. We have lots of options here. But we can prove that ABE, which is the whole top half of this figure, is the same as this one down here, and we can prove that with side, side, side. All right, so first off, I'm going to say that BE is congruent to CE. All right, now, I know that BE is congruent to CE because corresponding parts of congruent triangles are congruent. And we were told right here that BE and CE are congruent. All right, so now we know that. All right, now I know that AE is congruent to itself. So that's my third side. So AE is congruent to AE, and that is reflexive property. So now I know that this big top triangle right here is congruent to the bottom. So I'm going to search for my triangles here. Okay, so ABE, which is that top triangle, is congruent to ACE, and I know that because of side, side, side. All right, so now I know that that top triangle is congruent to the bottom triangle. Well, if the top triangle is congruent to the bottom triangle, then I know that this little angle up here is congruent to that little one down there, which was what we were being asked to prove. So now I'm looking for my angles. So BAD, so BAD is this little angle right here. It could also be called BAE, but it doesn't matter. And that one is congruent to CAD, which is what they had written for us. And we know because if we have congruent triangles, then all of the corresponding parts are going to be congruent. We know that that's true. All right, so let's go for it. Yes, and we got it. All right, I think that covers it. If you need to rewatch the original instructional video, but otherwise, you do need to continue to click New Problem until you get one that's asking you to prove something other than the triangles being congruent.